Hello, I'm Shamantak and welcome to this video of Easy IGCSE Maths. And today we're going to look at solving certain questions which involve trigonometric functions or use trigonometry to you along with other geometrical tools to solve a problem. And we are going to look at one of the most difficult geometry problems that was ever asked in IGCSE, which is the second one. But for that, there's some properties of the trigonometric functions that you should know. For sine of x, this is the graph. Basically, as you can see, it becomes 0 here, but even though it's a number which can't be exactly determined from the graph here, it's actually pi. It's 3.14. It's a non-recurring decimal. And in general, if you are drawing a graph, I would recommend you to do it like this: 0, then 0 here, as it's shown, then pi, and this is 2 pi. So basically use the x-axis as radians instead of normal numbers. And as you can see, the maximum value sine of x is 1, and the minimum is -1. So in terms of waves, this has an amplitude of 1. Now there are certain properties of the sine function, and that is, I'm just going to use a different color. Sine of x, say here, x, from this graph we can see it's, sorry, I'm just going to use a line, it's easier. Yep. From here we can see that it's, no, I would draw this because as you could see, the line was causing some problems. So this would be 180 degrees minus x, and they have the same y value. So sine of x equals sine of 180 degree minus x when x is between 0 and 180 degrees. Okay, now the second part, sine of 180 plus x equals, even though it says 180, that's my fault. It should be sine of 360 degrees minus x. Let's see how do we do that. 180 plus x. So let's say we take this value as x. I'm again going to use a different color. And this would be, now let's use a line. And it's going to be made black just for clarity's sake. And it drops around here. This is 180 plus x. This is 360. Sorry, it disappeared for a moment. 360 minus x. And these two are equal to each other. So as you can see, you basically use this formula when x is between 0 to 180 degrees, and you use the second formula, this one, when x is between 180 to 360 degrees. Okay, now cos of x. And there is this interesting pattern I would like you to notice. 1 minus 1, same amplitude. It looks eerily similar, right? Sine of x, cos of x. Well, if you are wondering this in terms of functional transformations, which is not covered in the scope of IGCSEs. Transformations are covered, not functional transformations. This is basically the cos of x is basically a horizontal translation of sine of x. And that's why they look so similar. And here, there's only one important formula. Cos of x equals cos of 360 degree minus x. Let's verify graphically. I'm going to use a different color here because the purple color kind of matches this color. So let's use red. So let x be this. Then use a line. Again, black. And then, so if this is x, this part where it reaches a max again, max of +1, is 2 pi. And this approx is pi. So 2 pi minus this approximately looks the same between 0 and x. So this length here is x. So this length is also x. So this point, the angle at which cos of x is equal to have the same y value is cos of 360 minus x. And this is basically true to the equation which has been established here. And now tan of x, which is completely different from sine of x and cos of x. This has a vertical asymptote when x equals pi by 2 plus pi times n for any integer n. What this means is that, say n equals 0, it means it has a vertical asymptote at pi by 2. And if n equals 1, it has a vertical asymptote at pi by 2 plus pi, which is 3 pi by 2. Then 5 pi, no, yeah, 5 pi by 2 and 7 pi by 2. So these are all points. This is a formula which describes when tan of x is going to have a vertical asymptote. And what does a vertical asymptote mean? It basically means that the function is not defined for that value of x. And the formula you need to remember, like these ones, is that tan of x equals tan of pi n plus x. So basically tan of 30, let's say, equals 180 plus 30, 210, 360 plus 30, 390, 540 plus 30, 570, and so on. Okay, now let's move on to the questions. As you can see here, I can immediately see it uses simultaneous equations and trigonometry. So it's a combination of two concepts, one from algebra and one from, well, trigonometry. So let's solve this. 2p plus q equals 2, p minus q equals half. If you add these both equations, it's 3p plus q minus q gets cancelled. 3p equals 2 plus minus half, so 2 minus half, which gives us 3 by 2, right? Yeah. So p equals 3 by 2 times 3, so it's 3 by 6, which is nothing but 1 by 2, or 0.5. So p equals 0.5. Immediately note that down. What about q? Just replace p equals 0.5 here. 2 times 0.5 is 1. 2 minus 1 is 1. So q equals 1. Now, see this question. It's a very intelligent question in my opinion, and you may miss it under the pressure of exams. Sine of u, I'm highlighting it by blue. And let me highlight cos of v by red. Now, assume sine of u is p and cos of v is q. Then what does the equation become? 2p plus q equals 2. P minus q equals minus half. The exact same equation as I. And from there, we know P equals 0.5, Q equals 1. So we assumed P to be sine of U. So sine of U equals 0.5, or U equals sine minus 1, or sine inverse. Sorry, it disappeared again. Sine inverse of 0.5. Inverse, so a negative 1 here. And this is 30 degrees. But there's a but. Remember, sine of x equals sine of 180 minus x for x between 0 to 180 degrees. So there would be another solution, which is 180 minus 130, 150 degrees. Write it down here. 30, 150. Similarly, solve for cos of v. I'm going to use red just to stay consistent. V cos of v equals q equals 1. So v equals cos negative 1, or cos inverse of 1. And the calculator would show you, well, that's 0. But cos of x equals cos of 360 minus x. So this is also equal to 360 minus 0, which is 360 degrees. And remember, our range is between 0 to 360. So the two values for v would be 0 and 360 degrees. And now we have all the tools required to tackle this extremely challenging geometry problem. A, B, C, D, E, F, G, H. Sounds like learning the alphabet, right? Is a regular octagon with sides of length 6 centimeters. So this whole thing would be 6. And right, 6. The diagram shows part of the octagon. O is the center of the octagon and M is the midpoint of AB. So this would be 3. This is also 3. Show that angle OAM is 67.5 degrees. Well, this is basically not the most complicated part. OM is common. I'm not writing this down. OM is common. AM, I'm going to write this down though. AM equals MB equals 3 centimeters, because M is a midpoint, mind you. And here this is 90 degrees, angle AMO. I'm going to highlight it. And angle OMB must also be 90 degrees, because because AMB is a straight line, and 90 plus 90 equals 180. So we have side, we have angle, and we have side again. So by SAS criterion of congruency, A triangle AOM, triangle AOM, triangle AMB, triangle AOM, triangle AMB, triangle AOM, 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 triangle AOM is congruent to triangle BOM. Now we can use this pretty cleverly. Now the octagon is made up of 8 such triangles. So this would be 360 degrees, because if you consider the octagon, it would be basically a complete circle. 360 degree by 8, which is 45. As triangle AOM and BOM are congruent, these angles, which I'm highlighting here, basically angle A, the angle OAM and angle OBM. See, we are now closer to solving the question, are equal, and let's say they're x. So 2x plus 45 degrees equals 180. So 180, 2x equals 180 minus 45, which is 135. So x equals 135 by 2. So x equals 135 by 2, or say which equals 67.5 degrees. Yeah, and we have shown that angle OAM, which is equal to x, is therefore 67.5 degrees. Okay, now calculate the area of the octagon. How do you do this? Well, there are 8 such triangles that make up this octagon. So it's 8 times, 8 times half, base is 6 centimeters, so half times 6 centimeters. And what is the height? Well, we know that MB equals 3 centimeters. We know that X, this angle, equals 67.5 degrees. Tan of 67.5 degrees, it would be the height by MB. So height equals MB times tan of 67.5 degrees, or 3 centimeters times tan of 67.5. So it's times 3 centimeters times tan of 67.5 degrees. And if you use a calculator, you would find that this would give you 174 centimeters squared. Okay, now part 2, find the area of the circle that passes to the vertices of the octagon. What would be the radius of the circle? It would basically be this side length, BO or AO. And how do you find that? You basically use Pythagoras' theorem. And that is, in this case, wait, first, area of a circle is pi r square. So it will be pi. And now we have to write an expression for the radius. And we are going to square that. So the expression for the radius would be the square root of, this is the hypotenuse and this is the right angle triangle. So we are squaring MO and adding it to the square of MB. MB square is basically 3 square, so that's 9. And 9 plus the height, or MO, is 3 times tan 67.5. It's 3 times tan 67.5 degrees whole square. Yes. And if you use your calculator, you're going to find that this simplifies to 193 centimeter squared. Okay, now the complex part, and I'm going to write this in dark purple. The diagram shows a horizontal container for water with a uniform cross-section. The cross-section is a semicircle. The radius of the semicircle is 0.45 meters, and the length of the container is 4 meters. Calculate the volume of the container. Part I is relatively easy, and you just need to use basic formula. Well, this is basically a semi-cylinder, you can call, and the volume of a cylinder is pi r square L, and this is half of that, so it's half pi r square L, and this equals half pi r is 0.45 meters, so 0.45 meters squared times L, which is 4 meters. Using your calculator, you would get that this is 1.27 meter cubed with three significant figures. And this question is a 6-pointer and is extremely difficult. The greatest depth of the water, the greatest depth of the water in the container is 0.3 meters. The diagram shows a cross section. Calculate the number of liters of water in the container. Give your answer correct to the nearest integer. What many of us would assume from this diagram is that, okay, this is a semicircle and we can just find the area of the cross section, then multiply that by 4 meters, and that would be our answer. But the thing is, it's not. This is not a semicircle. Rather, this is a semi-ellipse. This part, if we include it, would give us a semicircle. So how do we solve this now? We don't, the formulas for semi-ellipse, it's extremely complicated. It's not even teached at the grade 11 and 12. So how do we solve this? Well, let's try to be innovative. I just want to draw a line. Okay, I will just draw it using the pen because it seems complicated. Do it. Yep, that is it. It's kind of funny. Sorry for wasting your time, but I was just trying out. Yeah, and this. These are straight lines, okay? Just say for caution. And this is basically a radius of the semicircle. And we can say this is 0.45 hence. Same goes for this. So we've essentially created the sector of a circle. And with angle theta, let's say. From here, we can see this is a common side. This is 90, this is 90. These both are equal to 0.45 by RHS congruency. this would be, these two triangles are congruent. So this would be theta by 2, and so would this. And I think it's better to write down the 90-degree angles, or at least show them like this. Okay, now let's use a bit of trigonometry. Theta by 2, this is 0.45. Now we know that the radius is 0.45. This is 0.3. So this common height is 0.45 minus 0.3. It's 0.15. Okay, now we can use basic right angle trigonometry. Cos of theta by 2 equals base 0.15 over 0.45. This would simplify down to 1/3. So theta by 2 equals cos -1, or cos inverse of 1/3 so theta equals 2 times cos inverse of 1/3. Cos inverse -1. Okay, we now know theta. Well, what would be the area of this whole sector? I'm going to delete this because this basically hides the theta by 2 behind it. So the area of the whole sector is pi r square times theta by 360. Theta is this. So we're going to write 2 cos -1, 1/3 by 360 degrees times pi. I'm going to write it just here. Pi. Sorry, I'm just going to put a bracket here for clarity. R is 0.45, so it's 0.45 squared. Squared. This is the area of the whole sector, but we only want the area of the cross section, of the shaded part. So this would be subtracting the area of triangle A, B, C from the area of the total sector. Well, we can use the formula minus half A, B sine C to find the area of this triangle. How? So we are subtracting this area. Half AB would be basically like capital A, capital B, and capital A, capital C, both of which are 0.45. So it's times 0.45 times 0.45, which is 0.45 squared. And we are multiplying that by sine of the angle between them. So sine of theta, sine of this whole expression, sine of, wait, I'm just deleting this because it may look like a separating symbol between a numerator and denominator, even though these are two completely separate equations. So it is 2 sine of 2 cos inverse of 1/3. And let's put a whole bracket around this because this is the area of the cross section, and we need to find the volume. So we need to multiply this by 4. This would give us an answer in meter cubed, but we want it in liters. So how do we do this? Basically, 1 meter cubed equals 1,000 decimeter cubed, and 1 decimeter cubed equals 1 liter. So let's use a calculator. So this would give us an answer of 742 liters. And as you can see by this whole last equation, it's an extremely complicated problem that you need to apply your logical thinking, your mathematical reasoning, and also do a lot of mechanical steps to arrive to the final answer. I hope by solving this problem, some of the complex concepts related to geometry have been cleared, and I hope this has helped you in your academic endeavors. Thank you for watching.